Hi, good to see you again. Welcome to Block 2, Developing Geometric Reasoning, Lesson 11. I'll share my screen. So, in your previous lesson, you learned how to use your knowledge of parallel angle facts, angles on parallel lines, or facts about angles on parallel lines to solve different problems in geometry. In today's lesson, you're going to learn how to use known geometric facts or known geometric angle facts to obtain simple proofs. This is like the most difficult you're going to get, but it's not really challenging when you think about all the skills you've been learning. So you're going to bring together all those skills in algebra and in reasoning to understand this topic really well. So it is the last topic in block 2 of developing geometric reasoning. Remember to like the video, subscribe to the channel, share the video with those you think can benefit, and click on the notification bell so that when new videos are released, you will be notified. Thank you. Before we start, I would like you to pause the video and answer the retrieval practice questions in 2 minutes. Assuming you've paused the video and you've answered the retrieval practice questions, let's discuss them. So the first one, you were asked the sum of the interior angles in a triangle is 180 degrees. So this helps you recall those known geometric facts that we learned. Base angles in an isosceles triangle are equal. And then for this one, this is to help you recall your skill in simplifying algebra that we learned some time ago. So if you were to simplify this expression, you would collect like terms. So remember, you collect the terms, the signs next to the letter. So if I were to rewrite this, this will be 90 plus 90 subtract x and then subtract x. So you would see that simplifying this, the 2, of course, this is like saying minus, 1x minus 1x. So you would see that your result would be 180 minus 2x. For this one, let's imagine that we want to open the bracket up, okay? So we could simply rewrite this as 360 subtract x. So the subtraction sign is going to influence everything that is in the bracket. So we'll have subtract x and subtract 145. Now, if we rearrange this, this will be 360 subtract 145. So we're collecting like terms and then subtract x. So your result will actually be 215 subtract x. Take note of this skill because you're going to be using it in this lesson. Let's do some new learning. If you're asked to show that angle DFE is equal to 165 minus 3x, how do we do that? Have a think. Well, we know that the sum of the angles in a triangle is 180 degrees. So angle FDE, so this angle here, X, angle DEF, this angle here, 2x add 15, add angle DFE will be 180 degrees. So if we begin to substitute the terms in the equation, this is what we would have. So it would be x add 2x add 15, and then this here that we're looking for. Now, if we simplify this, this will be 3x, because x add 2x is 3x, add 15, plus this angle here that we're trying to prove to see whether we'll get this same result will be equal to 180 degrees. Now, Remember, when solving equations, we're going to isolate what we are actually interested in. So we are interested in isolating this term here, angle DFE. It could have been anything, could have been Y, could have been Z. Now, it means whatever is on the left hand side has to be eliminated, because the thing that is preventing us from doing that is the 3x and the 15 that is being added. So we can subtract 15 from both sides, which will give us 165. You can clearly see that 180 minus 15 will be 165. And next, we can subtract 3x from both sides. So we're doing two steps. So when we do this, we would see that our result would look like this, because we're subtracting from both sides to eliminate these. We're now left with this, so our proof is correct. We have been able to show that DFE, angle DFE is 165 minus 3x, because 180 minus 15 is 165, and then minus 3x. Let's look at this example. Diagrams are not drawn accurately here, but here we've been asked, depending on the size of angle X, are the two triangles always, sometimes, or never the same? Well, you may have tried different numbers to investigate this, but we know from our knowledge of triangles that these angles, for these triangles to be the same, angle X would have to be 60 degrees. So there are not a lot of cases where we can have different angles in which angle the triangles would be the same. So we're going to investigate this further as we look at further practice questions in this lesson. So it is sometimes only when X is 60 degrees. Pause the video and do some practice. Pause the video and answer question 1 in 1 minute. Assuming you've paused the video and you've answered question 1, here are the answers. Let's discuss them. For question 1a, you were asked, ABC is an isosceles triangle, and you can see the hatch marks there. Write an expression for the size of angle ACB. So we know that X is given to us here. And we know for an isosceles triangle that the base angles must be equal. So it means ACB should be X as well. For question B, you were asked to show that angle ABC, so ABC, would be 180 minus 2x. Of course, we've been also asked to give reasons to support our answer. Well, we know that the base angles would be equal. So if this is x, we know that x add x will be 2x. So it means 2x plus this angle here, ABC, would be equal to 180 degrees. So, and this angle, which is what we're looking for, is 180 degrees. So you can see why the expression for this angle would be 180 degrees minus 2x. Because if we solve this equation, we have to subtract 2x from both sides. Remember your equation solving skill. We eliminate that. So what we're actually looking for stand on its own. So ABC would be 180 minus 2x. This expression here, because angles in a triangle sum to 180 degrees. Pause the video and answer question 2 in 2 minutes. Assuming you've paused the video and you've answered question 2, here are the answers. Let's discuss them. For question 2, you were asked, DEF is an isosceles triangle. Show that angle EDF, so EDF, so this angle here, is equal to 180 minus x divided by 2. And you've been asked to give reasons to support your answer. Now, note that these angles, EDF, so EDF, and this angle, EFD, so this angle and this angle must, whatever you are going to have, must be what is left over. So the sum of these angles would be what is left over after we have taken this angle from 180 degrees. Why? Because angles in a triangle sum to 180 degrees. Now, for an isosceles triangle, the base angles must be equal. So it means whatever we have left, we have to divide it equally between these two angles. Now, this is what we have left. To divide it equally between the two means to divide by 2. And that is why you have this expression here. Pause the video and answer question 3 in 1 minute. Assuming you've paused the video and you've answered question 3, here are the answers. Let's discuss them. For question 3, you were asked to prove that angle X is equal to angle Y. And you were asked to give reasons for each step of your working. So the first thing we notice is that this is an isosceles triangle. You can see the hatch marks here. So it means that this angle here has to be X as well. The reason is base angles in an isosceles triangle are equal. Next, you see that these are crossed lines, crossed straight line segments. And we know that vertically opposite angles are equal. So we can say that Y is equal to X, or angle X is equal to angle Y. Let's look at new example for our learning. We've been asked to show that angle Y is equal to 180 minus A. So we're trying to prove that this angle here is equal to this expression. Well, we know that vertically opposite angles are equal. You can see it right here. These lines are crossed. So it means here could be A, although we've decided to label it another name B. But actually, if vertically opposite angles are equal, that could also be A. Now, remember what we learned about co-interior angles. Now, co-interior angles will sum to be 180 degrees. So this could have been written as A. So it means A add Y is equal to 180 degrees. Now, to get Y, we can subtract A from both sides. Remember your equation solving skill, and that will give us this expression. Let's look at another example, I think is the final one for this lesson. You've been asked to write an expression in terms of X for angle HLM. So this angle here. Now, have you noticed that if we were to look for that angle, we have just formed adjacent angles on a straight line sum to 180 degrees. So adjacent angles on a straight line sum to 180 degrees. So to get this angle, we can simply say it is 180 minus X. But what other angles can you form? Would you be able to find expressions in terms of X for all the missing angles? Of course we can, because we have sufficient information in the diagram to do so. We see here that these are base angles. Base angles of an isosceles triangle, because we have these hatch marks. So this angle should be X. That angle should be 180 minus X. Why? I'm sure you would have thought about adjacent angles on a straight line sum to 180 degrees. And inside this triangle, we know that to get this angle, we can simply do 180 minus the sum of these base angles. The sum of these base angles is 2x. So it will be 180 minus 2x. We see here that these are alternate angles. You can see the Z shape that links them, so that should be X. And here we can see that these are alternate as well, so that should be X. It's now time for you to practice all the knowledge you have been gathering. So pause the video and answer question 4 in 2 minutes. Assuming you've paused the video and you've answered question 4, here are the answers. So for question 4a, this is what your diagram should look like. And you've been asked to show that angle FYD, so angle FYD should be 180 minus L. Of course, you should know why, because you can see these two are resting on this straight line, which sum to 180 degrees. Angles on a straight line sum to 180 degrees. More precisely, adjacent angles on a straight line sum to 180 degrees. So mark your work and celebrate your success. Here is question 5. We've been asked that a triangle has interior angles A, B, and C. So pause the video and answer question 5 in 2 minutes. Assuming you've paused the video and you've answered question 5, here are the answers. Let's discuss them. For question 5, you were asked to show that D is equal to A plus B. How is that possible? Well, here are reasons for our answer. A plus B plus C will be 180 degrees. Now, because angles in a triangle sum to 180 degrees. Now, C plus D, all right, remember we've been told to show that D is equal to A at B. So let's see whether that would work. So C plus D will be equal to 180 degrees. Why? Adjacent angles on a straight line sum to 180 degrees. Now, if we look at this expression, we can see that the D is being represented by A at B. You can see it here. So we can say A at B is equal to D. Pause video and answer question 6 in 2 minutes. Assuming you've paused the video and you've answered question 6, here are the answers. Let's discuss them. Here you were asked that KLM is this triangle here, and you were told to prove that triangle KLM is an isosceles triangle, and you were asked to give reasons to support each stage of your working. So if we look at angle LMK, so LMK, we know that it's going to be 180 degrees minus this here. Why? The sum of adjacent angles on a straight line is 180 degrees. So this is the expression for this angle. So 180, remember when you write a fraction like this, the 2 is dividing the 180, and it's also dividing the q. So we can rewrite it as 180 minus 90 minus half q. Now, why? Because angles on a straight line sum to 180 degrees. Now, for the second part, if you look at LKM, so LKM, we know that this is Q. And we know that the sum of the angles in a triangle will be equal to 180 degrees. So it means to get, it means if this is an isosceles triangle, then either these two would be the base angles or these would be the base angles, and they would be equal. So let's see. So to get this angle here, LKM, would have to do 180 degrees minus this here plus q. All right, this one here. All right, plus q. And this is what we'll get. Now, simplifying this will be 180 minus 90 minus half q. All right. So when you finish, your expression will be 90 minus half q. Have you noticed that you have the same expression for this angle here as well as this angle here? So why have we done this? Because angles in a triangle sum to 180 degrees. Now you can see that LKM is exactly the same as LMK. So it's isosceles. So if we were to put hatch marks in this diagram, the hatch marks would be here. And just in case, for those of you who are confused about this, just in case you're confused, this negative sign here influences everything inside. So this is minus q minus 90 plus half, because this is plus half q. So when you simplify this, you would see that it's 180 minus 90. And then this is like saying q, all right, half q minus q, or a bit like saying half minus 1. Half minus 1 will be negative half. That's why you have 90 minus half q. Let's move on. Pause the video and answer question 7 in 2 minutes. Assuming you've paused the video and you've answered question 7, here are the answers. Let's discuss them. For question 7, you've been told QPR is an isosceles triangle, and you can see it here. So it means these base angles straight away have to be equal. PQ is perpendicular to QR. PS is perpendicular to QR. Prove that PS, so this one, bisects angle QPR. So we want to prove that it bisects QPR. Bisect means to split it into 2 equal parts. Now we've been asked to give reasons to support each stage of our working. Now looking at these, we can first start by saying PSQ, so PSQ must be 90 degrees. Okay, we can see that because it's a perpendicular line to that line there, because it is perpendicular to QR. So we established that. Next, we can see that QRP, so QRP must be 90 minus X. Why is that the case? Well, we see here that this would be the sum of the angles in a triangle is 180 degrees. All right. So first we know that the base angles in an isosceles triangle would be equal. We know that. But how do we establish that first? So if we know that the base angles must be equal, it means that if this angle were X and this is X, then whatever is left would have to be, if we add X, we know that is 90, then it means 180 minus 90 add X should give us whatever is left. So it's a bit like saying this angle here should be 90 minus X. Now, you can see it here. That's what we've done here. So which means that doing 180 minus 90 add X will be equal to X. All right. So using just this angle here, that will be equal to X. And using this triangle here, sorry, this triangle will be equal to x. And then using this triangle here, we'll get the same expression, 180 minus 90 minus 90 add x. Because remember, the expression has already been given to us that this here is 90 minus x. So this is 90 minus x as well. Okay? And that should give us our answer. So because we use doing this, simplifying this, we get the same variable x. It means it's been bisected. Bisected means split into equal parts. Pause the video and answer question 8 in 1 minute. Assuming you've paused the video and you've answered the question, here is the answer. So you've been asked to use rules of parallel lines to prove that the sum of the angles in a triangle is 180 degrees. And that's the proof here. So we know A at B at C will be 180 degrees because angles on a straight line sum to 180 degrees. D will be equal to A because alternate angles are equal. E will be equal to C because alternate angles are equal. And B at D at E must be equal to B at A at C. So the interior angles in here. And they would all be equal to 80 degrees regardless of how you look at them. So it means that the sum of angles in a triangle is 180 degrees, just using this method. And that brings us to the end of our lesson. So in this lesson, you have learned how to use known angle facts to obtain simple proofs. Well done for sticking around and for taking your learning seriously. Until next time, take really good care of yourself, and bye-bye.